Today we're going to be looking at understanding nets and understanding the parts of 3D shapes. Let's look at some jokes. Let's look at the different vocabulary associated with 3D nets. So in the last few lessons we've been talking about two-dimensional shapes. We've been finding the area of two-dimensional shapes, and eventually we'll be transitioning to finding the area of 3D shapes. A three-dimensional shape is here. The flat surfaces of a 3D shape are called a face. We're looking at this cube for the second part here. The segment formed by the intersection of two faces is called an edge. Each point formed by the intersection of three edges is called a vertex. Notice how it makes a V, and it's also a corner. A prism is a three-dimensional shape that has two parallel and congruent faces called bases, and all other faces are rectangles. Here are some common 3D shapes. Do you see how this shape here has triangles on both sides and the faces are rectangles? Determine the number and type of bases for the figures shown below. Well, we look at the base of what appears to be a pyramid here, and we see that it's a triangle. And how many triangles do we see at the base of our pyramid? There's one triangle. Therefore, it has to be D. Determine the number and type of bases for the figure shown below. So it appears to be we're given a prism here. If we look back at our definition of a prism is a three-dimensional shape that has two parallel and congruent faces called bases, and all other faces are rectangles. So how many bases and the type of bases are on this shape here? Where there's two rectangles on opposite sides for our bases, and there's two. So it has to be C. Determine the number and type of bases for the figure shown below. So this is the base. It looks circular. How many circles do you see? Just one. So it has to be B. Determine the number of edges in the figure shown below. What's the definition of an edge? An edge is the segment formed by the intersection of two faces. That's called an edge. It is literally the edge. So if you count the number of edges, you can see that there are 9. There are 9 edges on this triangular prism. So now let's transition over to nets. A net is the shape formed by unfolding a three-dimensional figure. Essentially, a net is composed of all the faces of a three-dimensional figure. Determine what solid can be made from the net below. The figure here is composed of 3 triangular faces and one triangular base. So we can say that this is, since it has triangular faces, we can say it's a pyramid, and the base is a triangle, so we can say that it's a triangular pyramid. Therefore, it is choice C here. Determine what solid can be made from the net below. If we look at our faces here, we can see that they're rectangles. And if we remember back from earlier, the definition of a prism is a three-dimensional shape that has two parallel and congruent faces called bases, and all the other faces are rectangles. So here, we're looking at a rectangular prism. Determine which of the following nets cannot be used to make a cube. To determine whether something can be formed as a cube, we choose one of the bases and we fold it around that base. Notice that for B here, no matter how I fold my squares around my base, it does not form a cube. So our answer choice then is B. Next question. Determine which of the following nets cannot be used to make a cube. Much like the last question, we'll choose a square and try to fold it up around that base. However, if you look at D here, no matter which base we choose as a square, we cannot fold it up to form a cube. So therefore, it's D. Determine what solid can be made from the net below. I look at this and I recognize straight that it's a prism. If you remember, a prism is a three-dimensional shape that has two parallel and congruent faces called bases, and all the other faces are rectangles. So here we're given a whole bunch of rectangles. So we know that it's going to be a prism. And its bases are triangular, so we have a triangular prism. So our answer choice is C, a triangular prism. Today, you learned how to understand nets and understand the parts of 3D shapes. Thanks for tuning in.
Here is a circle, it knows how to get around. It has a radius from center to rim, and its diameter's a line that goes from side to side while passing through the center. Now isn't that simple? Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Here is a circle, it knows how to get around. It has a radius from center to rim, and its diameter's a line that goes from side to side while passing through the center. Now isn't that simple? Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d.